Thanks for joining me for this video. We will be discussing factoring trinomials. So we're going to be factoring using two different techniques, and the techniques are dependent upon if there is a number in front of the x squared other than 1. So if you look at numbers 1, 2, and 3, you can see that there is not a number written in front of the x squared or n squared or t squared. So it's understood to have a 1 as a coefficient. That's going to be a much shorter process than if it has a number in front of the squared term. So we're going to have two processes to learn. The key to using these processes or knowing when to use these processes is by identifying how many terms you have in your polynomial. So a 4-term polynomial, we use a process called factor by grouping. A 2-term polynomial, you might have a difference of squares, a difference of cubes, a sum of cubes, or a sum of squares. Sum of squares is not factorable. So the number of terms you have determines how you should proceed with your factoring. So for these, number 1, we're going to think about what we've done in the past, which is multiply. So let's look at something like this. If I asked you to multiply or find the product or some similar directions, you would multiply these out. So you would do x times x is x squared, x times 2 is 2x, negative 3 times x is negative 3x, and negative 3 times 2 is negative 6. And then you would notice that you have like terms in the middle, and so you would add those together. Positive 2x minus 3x is negative x, and you would get that trinomial. So now we're trying to go backwards. We're given the polynomial, and we're asked to factor it. So let's look and see where we got these pieces. So first of all, x times x, the first terms multiplied together, give us the x squared. So we're going to be splitting up x squared into x and x as our first terms in the binomials. Next, if we look at the last term, this negative 6, notice we get that's the last, from multiplying the last two together. So negative 3 times negative 2 gives us that negative 6. And then the last piece to look at is this middle. Notice that the coefficient of that is a negative 1, right? And I got that by combining my like terms. So adding those together. So negative 3x plus 2x, if I add those together, I get negative 1x. So that comes from the outer and the inner. In other words, we're adding the 2 and the negative 3. We're adding those to get that middle. Okay, so when we are factoring from the polynomial, keeping in mind what we just saw, we're looking to find out what multiplies to get the constant. So what numbers multiply to get 12, but will add to get 7. So that's what we're trying to find out. So if you're trying to multiply to get the last number, so your product is 12, you can just make a chart of all the numbers that multiply to get 12. So 1 times 12, 2 times 6, 3 times 4. That's the only way you can multiply two whole numbers to get 12. And so now you just want to go down the list and say, okay, well, which ones add to get 7? Well, 1 and 12 don't add or subtract to get 7. 2 or 6 don't, but 3 and 4 do. 3 plus 4 is 7. So those 3 and 4 are the factors that you want to use. So 2 sets of parentheses. The first have to multiply to get x squared. The only way to do that is x and x. The second pieces have to multiply to get 12. And the numbers that multiply to get 12 but also add to get 7 are 3 and 4. So 3 and 4. And they were both positive. So that's the factors that work. X plus 3 and x plus 4. And if you're not sure, you can always multiply them out and you'll see that you get back to that original. All right, let's look at number 2. So number 2, this is the process that you will use if there is a 1 in front of the n squared. So we just have an n squared, coefficient of 1. So I can automatically start by writing my parentheses. And n squared is going to break up into n times n. Now I need to figure out what multiplies. So multiplies to get 14. So I want to make a list of what can multiply to get 14. So 1 times 14, 2 times 7, and that's it. So one of these should add or subtract to get 9. So the sum needs to be 9. Well, 1 and 14 don't add or subtract to get 9, so that's not it. Oh, and in fact, look, I forgot. It should be negative 9, right? I've got a negative in the equation or in the expression. Okay, so let's talk about how that changes things. I need these to add or subtract to get 9. So I'm going to have to finagle my signs to make it work. What if I had a negative 2 and a negative 7? A negative times a negative is a positive, so that will still give me a positive 14, but when I add them, it will give me a negative 9. So those are the numbers that I want to use now, is a negative 2 and a negative 7. So I'm going to have a negative 2 and a negative 7. And those are the factors that would work for this case. Something to keep in mind, so you can make the chart every time like this and it works, and just play with the signs until you find what works. But there's also a way to kind of figure out what's going on. If this last sign, so if the sign of the constant, the last sign is positive, it means the signs in your binomials will be the same. So see how you got 2 pluses? What sign you use will be the sign in front of the x term. So these signs are going to be the same and they're going to match that sign. So this plus means same sign. So see, they're the same and they match the sign in front of the 9n. So that being said, if we look at number 3, this is a minus. If a plus means you have the same sign, what do you think a minus means? If you think it means you'll have different signs, you're correct. So since we have a negative in front of the 8, that means we're going to have different signs in our 2 binomials. So since we have a 1 in front of the t squared, we can automatically set up our parentheses and we break up the t squared by using t and t. This minus means we're going to have different signs. So we'll have 1 plus and 1 minus. Keep in mind if the signs are the same, like in number 1 and 2, you're going to be adding the 2 numbers together to get the middle number. So 3 plus 4 was 7. Negative 2 plus negative 7 is negative 9. But if the signs are different, you're looking for a difference in the 2 numbers to make the middle. So let's just make our chart and see what I'm talking about. So this is multiplies to get negative 8. So our product needs to be negative 8. And our sum needs to be negative 2. So what multiplies to get 8? 1 and 8, 2 and 4, and that's it. Since our signs are different, we should be looking for a difference. So 1 plus 8 is 9, 1 minus 8 is 7, so that's not 2. But 2 and 4, they add to 6, but the difference is 2, so that could work. Since I need a -8, one of these two numbers is going to have to be negative. If I make the 2 a negative, that would multiply to get -8, but notice that if I add those, I get a +2, and I need a -2. So I need to have a -4, and then that would add to a -2. So there are my numbers. A +2 and a -4 will multiply to get -8 and add to get -2. The other thing that this sign tells you, because see in number 1 and 2 that told you what sign you're going to use, but this time they're different. If they're different, this sign tells you that it's going to be the sign of the larger number. So since 4 was bigger than 2, 4 gets that sign. So 4 gets the negative. Okay, let's look at number 4. So number 4, we have a trinomial. We see the 2 in front, so that could be an issue. But look and see the 2, the 6, and the 36. Those are all divisible by 2. So this time 2 is our greatest common factor, and I can divide it out. So don't forget to look for that. If I divide out a 2, I'm going to have y squared plus 3y minus 18. Now remember I said that if you have a square or an exponent on your variable, you should check to see if it will factor again. So I'm going to remind myself that I have this GCF and I need to bring it down in my final answer. But for now, I'm just going to focus on what's in parentheses because I want to see if I can factor it again. So since it's a y squared with no number in front, I can factor it into 2 parentheses, break up y squared with y and y. And then I need to know what multiplies to get -18. And then adds to get 3. So let's think about our signs. This sign is a negative. That means we're going to have different signs. So 1 plus, 1 minus. So we're going to keep that in mind. So how can I multiply to get 18? 1 and 18, 2 and 9, 3 and 6, and I think that's it. So we're looking for the numbers that have a difference of 3 because the signs were different. So not 1 and 18, not 2 and 9, 3 and 6. Since this sign, since the sign in front of the 3y is positive, that means your bigger number should be positive. So that means the 3 should be negative. -3 times 6 is a -18, and a -3 plus 6 is 3. So that works. So here are the numbers I want to use. -3 and +6. Don't forget to put that 2 in front, the GCF I found in the beginning, and that would be fully factored. Okay, so 1 through 4 were examples of when I have a 1 in front of the square term. Even number 4 ended up being that way because we could factor out a GCF. But if you look at number 5, there is no GCF. So that leaves us with that 4 in front. Our goal here is to make this trinomial become a 4-term polynomial so that we can use factor by grouping. So if you do not know how to do factor by grouping, you should look that up. I do have a video on that as well, so watch that so that you can kind of see the technique that you will use in this example. What we have to do is set it up. So we're going to set it up by multiplying what's called A and C. So the reason they call it that is because this is a quadratic expression and the coefficient of x squared is referred to as A and the constant is called C. And so we're multiplying A times C, the coefficient of x squared times the constant. So this is referred to sometimes as the AC method or the factor by grouping method. So we're going to start by multiplying 4 times negative 3. And that's what we're going to want our product to be. So in the first 4 examples, we simply used the last term, the constant term, for our product. Now we're going to be multiplying 4 times negative 3 to get negative 12. The sum is going to be the middle term, the b, which is 4. So let's look and see what we have options for. 1 and 12, 2 and 6, 3 and 4, and that's it. Notice that this sign in front of the 3 is a negative. So our signs are going to be different. That means we're going to be looking for a difference between the two numbers to make 4. So 1 and 12 is not it. The difference between 2 and 6 is 4, so that's going to be an option. The difference between 3 and 4 is 1, so that's not an option. So 2 and 6 has to be it. Notice that the number in front of the 4 is positive, so that means the larger number has to be positive. So that tells me that the 2 needs to be negative. So negative 2 times 6 is negative 12, and negative 2 plus 6 is positive 4. So this is the pair that works. This is where it gets different. You are going to have to bring down the first term, and this middle term, this 4z, you're going to break it up into these two numbers, these two factors. So you're going to have negative 2z plus 6z and bring down the minus 3. Okay, quick break. I'm going to go back up to the top and remind you what we're doing is we're breaking it up into this part. See how when we multiply, when we FOIL it out, we get 4-term polynomial, and then we add our like terms in the middle to make it 3 terms. When we're working our way backwards and we have a number in front, we're not going to skip that intermediate step. We're going to go from having a 3-term polynomial to a 4-term polynomial and then get our factors. So now that we have 4 terms, we're just going to do factor by grouping. And so hopefully this is a process that you are familiar with. So we're looking for common factor in the first pair. So I could divide out a 2, and I could also divide out a z. So 2z is the common factor. And that would leave me 2z minus, the 2's cancel, the z's cancel. So since everything cancels out, it's dividing out. Remember, it leaves a 1. Bring down the sign, so plus 6z and 3. I could factor out a 3. So now I'm going to have 2z minus 1. Notice that what's in parentheses is the same. It should always work out that way if you can factor by grouping. So now 2z minus 1 is like, and 2z plus 3, what's in blue, makes up your other factor. And that is the factorization of number 5. So if that was clear as mud, we've got 3 more to work through that will hopefully help you. So number 6, we have a 3-term polynomial, so a trinomial. We do not have a GCF among all 3 terms. So since we have a number in front of the u squared, that lets us know that we have to do the longer AC method. So we're going to start by multiplying a times c. So 21 times 2. So that's 42. And we want the sum to be the middle number, which is 17. I have no clue what's going to work, so let's just start making a list. 1 times 42. 42 divided by 2 is 21. 42 divided by 3, I don't know what that is. It's 14. 42 divided by 4, that won't work. 42 is not divisible by 5. It is divisible by 6, so 6 and 7. And then that'll be our exhaustive list there. So those are all the possibilities. So now let's look at our signs in our equation, or I'm sorry, in our expression. Since this is a plus, that tells us that our signs have to be the same. They're both going to be a positive since the 17 is positive. So I'm looking for a sum that is 17. So 1 plus 42 is not it. 2 plus 21 is 23. 3 plus 14 is 17. So that works. 6 plus 7 is 13. So the only option is 3 and 14. Remember, in this method, you are not going to start with parentheses. You're going to start by rewriting the middle term using the two pieces you find in your chart. So now we'll have plus 3u plus 14u and bring down the 2. Again, notice if you added your like terms here, you get back to where you started. So we're just going to do factor by grouping. So the first pair, 21 and 3, are both divisible by 3. These both have a u, so I can factor out a 3u. And when I divide out a 3u, I will have a 7u left and a plus 1. Bring down the plus. 14 and 2 are both evenly divisible by 2, so I'm going to divide that out. And that will give me, don't forget to write down the 2, what you divide out. And then that will give me a 7u plus 1. Notice that what's in green, what's in parentheses, is the same. It should always be like that if you can do the factor by grouping method. So what's in green is one factor, and then the leftovers, the outside part, the part in blue, is your second factor. And so that is the factored version of number 6. Hopefully seeing that second example helped. We're going to look at 2 more. So number 7, we have 3 terms. There's a number in front of the x squared. We're going to look to see if we have a common factor. This time it looks like we do. Can't we divide everything by 3? So let's try. Everything looks like it's divisible by 3. So if I divide out a 3, I will have 2x squared minus 5x plus 2 left. Okay, so I had a GCF there. Now I want to look and see if I can factor what's in parentheses again. So since I still have an exponent, I'm suspicious that I'm not done, so I'm going to check on that. So I'm going to remind myself, eventually I need to bring my 3 down, but for now I'm going to ignore it and just focus on what's in parentheses. So the x squared still has a number in front. I still have 3 terms, so I'm going to try the AC method. So the product is going to be 2 times 2, which is 4, and the sum should be the middle number, which is -5. Since this sign in front of the 2 is a positive, that means I'm going to have the same sign, and the number in front of the 5 is negative, so that tells me they're both going to be negative. So what can multiply to get 4? Well, 1 and 5, and I just said they both have to be negative. Oh, not 1 and 5. 1 and 4, right? 1 times 4 is 4, and 2 times 2 is 4. So -1 plus -4 is -5, so that will work. -2 and -2 is -4, so that does not work. So it has to be -1 and -4. So bring down 2x squared, break up -5x into -1x minus 4x, bring down the plus 2, and now do the factor by grouping technique. So the first 2, no numbers in common but x, so I can factor out an x, and that leaves me 2x minus 1. Bring down the negative. 4x and 2 can both be divided by 2, and since I brought down the negative, that means I'm factoring out that negative. So I'm factoring out a -2, and that's going to give me 2x, and then we have 2 divided by -2 will give me a -1. So what's in green, what's in parentheses matches. So that's one factor. And then what's in the front makes up the other factor. And then I can't forget that 3 that I had as a greatest common factor that goes in the front. And that is the factored form of number 7. All right, number 8, our last example. It looks like I'm going to run out of space here with this chart, so I'm going to erase this chart. All right, so the first thing we want to look at is there a greatest common factor among all 3 terms? And at first I was thinking 4, because 4 can go into 4 and 4 goes into 12, but 4 does not go into 9. And then 3 looked good for 9 and 12, but not 4. So it doesn't look like we have a greatest common factor among all 3 terms. So since I have 3 terms and there's a number in front of the x squared other than a 1, I need to do factor by grouping. So I want my product to be 4 times 9, which is 36. And I want my sum to be 12. If I'm looking at my signs to try to get a hint, I know that the sign in front of the 9 is a positive, so the signs will be the same. And since the sign in front of the 12 is positive, they're both going to be a plus. So let's see what I can multiply to get 36. 1 times 36. 36 is divisible by 2, that's 18. 36 is divisible by 3, I think that's 12. Is divisible by 4, and I think that's 9. It's not divisible by 5, but it is by 6. 6 times 6. So that will be our full list. So I need them to add to get 12. Well, not 1 and 36, not 2 and 18, not 3 and 12. 4 and 9, that's 13. 6 and 6 is 12. So that's going to be what works. So we bring down the 4x squared, split apart the 12x into 6x and 6x, and then bring down the plus 9. Now that we have 4 terms, we're going to do factor by grouping. So it looks like I can divide the first 2 by 2x. So if I factor out a 2x, I will have 2x plus 3 left. I can pull out, it looks like a 3 from the next pair, bring down that plus. Oops, almost forgot to write the 3 down. So now that's going to be 2x plus 3. Again, notice that what's in green, what's in the parentheses is the same. So that's one factor. And then the other factor comes from what's in front, 2x plus 3. Notice that those are the same. The green and the blue are both 2x plus 3. If you have a repeated factor like that, it happens twice. So you could write it like that, 2x plus 3 quantity squared. So that would be the best way to write that one.